Here's the review for your probability quiz coming up. First one here, we're given a spinner, which has these 8 different spots. So that means that we should have 8 different options for what your spinner could be. First thing says, what's the probability of getting a 2 on this spinner? Well, there's only 1 2 on here out of 8 different options. 1 out of 8 is your probability. Next one, probability of getting an odd. Well, your odds are 1, 3, 5, and 7. So there are 4 options out of your 8 total, which is 1 out of 2. Number 3, probability of getting a 6 or an odd. Well, probability of getting a 6 is just the 6, which is 1 out of 8. Probability of getting an odd, we just said, was 1 out of 2, or 4 out of 8. And when we say the word or, we always say add. Or means add, so 5 out of 8. Number 4, probability of getting a multiple of 2 or multiple of 3. Well, the multiples of 2 are 2, 4, 6, and 8. Multiples of 3 are 3 and 6. Those are the ones that are on here. So there's 4 multiples of 2, so that's 4 out of 8. There's 2 multiples of 6, that's 2 out of 8. However, notice what I have here. I have 6 listed twice. So really the only numbers I have are 2, 4, 6, 8, and 3. So it should only be 5 out of 8, because really I can't count that 6 the second time. So 4 out of 8 plus 1 out of 8 gives me 5 out of 8. And the last one, probability of getting a 9. Well, there is no 9 out there. So 0 out of 8, or just 0. Okay, next section, dealing with dice. And I'll even be nice and color in this blue die on this number cube. What is first the probability that both cubes land on 1? Before I even start, I want to say how many different options there are. Well, each number cube is numbered 1 through 6. So I have 6 options for each cube. So 6 for the first one and 6 for the second one. When we say and, that's when we multiply. So there are 36 total options with each roll of the dice. So the probability that both cubes land on a 1, that would be a 1 out of 6 for the first guy and a 1 out of 6 for the second guy. So 1 out of 36 is your answer. Number 7, the probability that the white number cube is an odd number and the blue number cube is bigger than 4. So probability that we get an odd number would be 1, 3, and 5. So that's 3 out of 6 for the first cube. And for it to be bigger than 4. So that means this cube needs to be a 5 or a 6. So 5 and 6, that's 2 out of 6 options. So now I just got to simplify it. I'm going to reduce first, make this 1 out of 2 and 1 out of 3. So my answer is 1 out of 6. Next one is probability that the blue cube is bigger than the white cube. 8 here and then 9 as well are ones that you really can't just do any simple multiplying or adding. I kind of want to list these ones out. So for the blue cube to be bigger than the white cube, well, my white options are 1, 2, 3, 4, 5, and 6. For the blue cube to be bigger than a 1, my options, it can't be a 1. That doesn't work, but it could be a 2, 3, 4, 5, or 6. For 2, well, 1's not going to work, 2's not going to work because they're not bigger, but 3, 4, 5, and 6 all do work. For 3, 4, 5, and 6 will work. For 4, a 5 and a 6 will work. For 5, only 6 will work. And if I roll a 6 on a white cube, there's no way I'm going to get anything bigger. So these are my only options, is if one of those techniques happen. So there's 5, 9, 12, 14, 15 different ways that it'll work out of my 36 total options that we have. Which means when I simplify that, divide them both by 3, I should get 5 out of 12 as my probability. Next one, that they add up to 9. We're going to go through the same idea. I'm going to list off the options, 1, 2, 3, 4, 5, and 6, and see what it takes to get up to 9. Well, 1 plus 8 gives you 9, I can't get an 8. 2 plus 7 gives you 9, I can't get a 7. 3 and 6 get you 9, so that'll work. 4 and 5 get you 9, 5 and 4 get you 9, 6 and 3 will get you 9. So those 4 possibilities are the only ones that'll work out of the 36 total that we said we had. So that means 1 out of 9 is my final probability. And number 10, the probability that the white cube is odd and the blue cube is even. So again, when I say the word and, I multiply. The white cube being odd, we said earlier, being odd was 3 out of 6. And the blue cube being even, there's also 3 options there, 3 out of 6. Each of those will reduce to be 1/2. 1 out of 2, so 1/2 times 1/2, multiply straight across, and get 1 out of 4. Alright, now, dealing with the decks of cards. It gives you all the information up here. 52 cards, There are 4 different suits, 13 cards in each suit. We need to figure out all these different probabilities. Here they are, 52 total options are what we're going to have. So first, the probability of getting a 2. Here are my 2s. There are 1, 2, 3, 4 of them. So 4 out of my 52, which would reduce to 1 out of 13, which would make sense. 1 out of the 13 cards that are shared by each suit. 2, the probability of a red card. Well, the diamonds are red and the hearts are red. So both of those will all count. There's 26 of them out of 52 total, so 1 out of 2 when I reduce. Or look at it as, okay, there's 4 suits, 2 of the suits are red. That's 2 out of 4, which also is 1/2. 13, probability of getting a king or a queen. So there's the queens, or there's the kings, there's the queens. So I have a total of 4 queens out of 52 and 4 kings out of 52. So that means I'm going to have an answer of 8 out of 52, which should reduce to be 2 out of 13. Next up is talking about getting a jack and a diamond. Well, here are my jacks. Here are my diamonds. Which one is both a jack and a diamond? Well, the jack of diamonds is the only thing that is. There's only one jack of diamonds out of 52 total. For 15, probability of getting a jack or a diamond. So with and in the last problem, we multiplied. With the or, we're going to add. So probability of getting a jack, there's 4 jacks there out of 52. And there are 13 diamonds out of 52. However, kind of like the problem we did earlier with the multiples of 2 and 3, we can't count the jack as both a jack and a diamond, because otherwise I'm counting too many. So really, I need to count 1 less. I need to take away the overlap. So 16 out of 52 would be my answer, which reduces here to be 8 out of 26 and 4 out of 13. Other way you can look at it, just literally mark them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, I already counted that, 15, 16 different cards out of 52 that will work. When all else fails, write them out or draw them out, or in this case they're already drawn out for you, so just mark them straight off to find your answer. Next set is talking about face cards. A face card is literally a card with a face on it. A jack, queen, or king are the ones that have a face on it. So the probability of getting a face card, well, there's 3 of each suit. That's 12 total out of 52, which would reduce to 6 out of 26 or 3 out of 13. To be a face card and a spade. Well, here are my face cards again. Would be all these. The ones that are spades are just those 3. So just 3 out of 52 as that answer. Number 18, a face card or a spade. Okay, so for it to be a face card or a spade, again, same idea. There were 12 total face cards out of 52. There were 13 total spades out of 52. However, how many did we end up double counting? Well, the ones that are both, the 3 out of 52. So really I need to take back away my excess that I have here. So what I'm going to do here, 12 plus 13 is 25. Minus 3 is 22, so 22 out of 52, which will reduce to 11 out of 26. And again, kind of like we did in the other one, all we have to do really is kind of mark them off. So face card or spades. Here's my face cards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then count spades, so 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Well, those 3 I already counted. I don't need to count anymore. 22 out of 52 is your answer. Now 19, you have to draw 2 cards for a poker hand. What's the probability that you pick out an ace, you don't put that card back, and then you draw another ace? Well, there's 4 aces here. So your first option, there's 4 out of 52 chance that you're going to draw an ace out of the pile. You're not going to put it back now. So there's only 3 aces left to get in your second option. 3 out of, there's only 51 total left to get your, or to finish up, I should say, your poker hand. So 4 times 52, 3 times 51, and you would try to simplify that. And when you do, you actually get 1 out of 884 as your probability. So 1 in 884 chance of getting your pair of aces in your hand. Not very good odds. Okay, last couple pages here, the marbles. Probability of being a striped marble. Again, I'm going to look at my total options first. My total, there are 10 marbles in here, 3 striped, 6 white, and 1 black. So the probability of getting a striped marble is 3 striped marbles out of my 10 total. 21, probability of getting a striped marble, putting it back in, and drawing another striped marble. So I'm going to multiply because it says and. The first striped marble, there's 3 of them out of 10 total. When I put it back in, I'm still going to have 3 striped marbles out of 10. So I'm just going to multiply them and get 9 out of 100. Now, 22 is the same idea except we're not putting the marble back in. So you still have a 3 out of 10 chance of getting that first striped marble. However, now that we've done that, we've gotten rid of that striped marble. Now there's only 2 of them left out of 9 total. So now I can just go and simplify and get my answer. So 3 and 9 can cross cancel to be 1 and 3, 2 and 10 to be 1 and 5, so 1 out of 15 would be my probability when it's simplified. Okay, these next two, the same thing, only with the black marble instead. So let me get rid of that. For the black marble, probability of getting a black marble is 1 out of 10. I put it back in, so now I'm drawing again with the exact same probability. 1 out of 10, multiply 1 out of 100. And 24, probability of getting a black marble, this time not putting it back in. So it's still 1 out of 10 for my first option. I've taken the black marble out now, so now the probability of getting a black marble, there's none left. So 0 out of 9 probability there. Multiply straight across, and I get 0 out of 90, 0, as my probability. Can't be done, obviously, because there's only 1 black marble. I can't pick 2 of them out of the bag. Okay, last set. You roll a number cube, you flip a coin, and you spin the spinner from the first page. What's the probability that you roll a 3, the coin lands on heads, and the spinner lands on a multiple of 3? So I have 3 different things going on with the word and in between. So I'm going to have to multiply 3 different probabilities. First one, you roll a 3 on a number cube. There's 1 3 on there out of 6 options. The coin lands on heads. Well, the probability in heads is 1 out of 2. And the spinner lands on a multiple of 3 on that first page. There were 2 multiples of 3 out of the 8 total. Or that reduces, if you want, to 1 out of 4. So when I multiply these, multiply straight across, I get 1 up top, and this should become 48 on the bottom. 1 out of 48. 26. You flip a penny, a nickel, and a quarter. What's the probability you get exactly 2 of them to land on tails? Okay, so all you're going to do with this, they say, is to draw out all the possible outcomes. So what I'm going to do here is I'm going to say, well, I'm going to do it down here. I have a penny, I have a nickel, and I have a quarter. My options are, well, all 3 of them could end up heads. Or I could say, okay, the penny and nickel are heads, but the quarter is tails. Before I go any further, I should say, how many total options should I have? Well, my penny has 2 choices, my nickel has 2 choices, my quarter has 2 choices. I have to flip all of them. Penny and nickel and quarter. So I should have 8 total options when I'm done here. So let's make sure I get to that. Okay, so now, what if the penny is still heads? Maybe now the nickel is tails. Well, the quarter could be either heads or it could be tails. Well, now I have the options here. Well, what if all this happens, but instead of the penny being heads, what if it's tails now? Well, guess what? Those are my 8 options. So the other 2 can be heads. We can have heads and tails. We can have tails and heads. Or we can have tails and tails. So we need to see which ones have exactly 2 tails. Well, there's one of them, there's one of them, and there's one of them. So there's a total of 3 out of my 8 that have exactly 2 quarters landing on tails. And the last one, probability of winning a Powerball is about the same as getting heads 21 times in a row when you flip a coin. So what's this probability? So that means you flip a coin, it lands on heads, and you flip it again, and it lands on heads again, and it lands on heads again, over and over again 21 times. Probability of it landing on heads is 1 out of 2. And the second time, 1 out of 2. And the third time, 1 out of 2. And so on and so forth. 21 times I have to do this 1 out of 2. When I multiply those probabilities, I'd get 1 up top. I'm going to get on the bottom. 2 times 2 times 2 times 2. 21 times. That's 2 to the 21st power. Which is, when you multiply that out, 2,097,152. That's approximately what the odds are of winning the Powerball lottery. So you think you can land on heads 21 times in a row, then you should go out and buy yourself a lottery ticket. Otherwise, no thanks. There you have it, everything for probability. Good luck, study well, practice, practice.